Welcome all of you to this video of Maths Made Easy. In this video, we are going to take up the important questions of HNO3 as you can see. Okay, please subscribe the channel if you haven't by now, because I shall be uploading many more videos of important questions of physics very soon. Okay, once Maths and Chemistry is over, I shall be doing it for physics. Okay. Once ICSE and CBSE is over, I shall be uploading videos on 11th and 12th syllabus, okay, all chapters and concept wise explanation of concepts. Okay, so again I want to tell you all here, these are not the only equations that you have to study, they are important equations. That means these are your priority, that is it. So once you know these equations, please learn the other parts of the chapter if you have time. So I am only taking up these questions because these are the often repeated questions in ICSE. Okay, then let us start. Now, industrial method is important in all the acids. Okay, Haber's in ammonia, then contact in H2SO4, now Oswald's. Okay, here we shall be ammonia plus oxygen. We just oxidized this, formed nitric oxide plus H2O. You can balance it later. Platinum catalyst 700 to 800 degrees centigrade. So this is my first equation. This one I will oxidize further. NO is oxidized further to form NO2. Okay. Now NO2 plus O2 plus H2O will give the HNO3 that we want. So learn the steps. They are never going to ask you the figure. They will never ask you the figure for this. Okay. But then they will ask you questions based on the figure. They will ask you give reasons, know the chambers. So first you have to know the different equations. That will only help you to remember the chambers. Okay, which is the oxidizing chamber and which is the final formation of acid, how it is done. So there can be many small questions based on the Oswald's process, based on the diagram. Okay, but these are the three main equations that you must learn. Okay. Now one thing I want to tell you all. Nitric acid has two very important properties. One is an oxidizing property and the other one is it is a very volatile acid. Just like H2SO4 was a non-volatile acid, and because of that it found many uses. Similarly, HNO3 is a volatile acid, and because of that it is not used in many cases. What does volatile acid mean? Volatile means if you just leave it at room temperature, it will evaporate and it will reduce in quantity. Okay, so even if you keep it in the lab in a bottle, what will happen is the HNO3 bottle, the nitric acid bottle, is always yellowish brown, and that comes as a question. Okay, why is the bottle of nitric acid always yellowish brown in room temperature? The reason is this, that HNO3, if you keep it at room temperature, it will split into this. It will split into this. Now this is the reason behind the reddish brown color or the yellowish brown color, because nitrogen dioxide has a reddish brown color. So this is the reason why it gets colored like that. So chemistry teachers, even without seeing the label, they can tell which is the bottle of nitric acid. The reason is this, and the reason is volatile nature. Okay, second thing is its oxidizing nature. Here is the reason for it. So nitric acid, when it decomposes, it gives out oxygen, and so it has the capacity of oxidizing many substances. Okay, so we'll see one reaction which will show its oxidizing reaction. This is also asked in many question papers. Here if you see how it reacts with, okay, this is, okay, so here it reacts with sulfur. I'm not balancing it, you can do that. This is hot conc. Okay, hot and concentrated HNO3 when reacts with sulfur gives out sulfuric acid and nitrogen dioxide and water. Very important reaction. Now, two very important equations of that is asked in ICSE very often is nitric acid, how it behaves with copper when it is dilute, and how it behaves with copper when it is very concentrated. Okay, so copper plus HNO3 dilute first. Okay, CuNO3 twice plus, don't forget to write this way, plus H2O plus the gas that is given out is nitric oxide, NO. You can balance it. Now let's see for copper and HNO3, the same two substances, now it is concentrated. It is copper nitrate, okay, plus H2O. Now see, here is the change. So the only change happens here, okay, nitric oxide and nitrogen dioxide. Very often asked from nitric acid. Know it and go, okay. One very important question of nitric acid is this, the brown ring test. We can't leave it out. It's that important. Okay. Even if it has come last year, please learn it this year. Okay. So brown ring test tests which radical? Nitrate. It tests nitrate radical. So we can do it with nitric acid. We can even use any other nitrate for it. FeSO4 solution, freshly made. Okay, solution has to be freshly made, and that is you are mixing water in it. Plus, it can be HNO3 or it can be some other nitrate. What is important is this nitrate radical. Okay, FeSO4 dot NO. Okay, this is the reason for the brown ring. But where does the sulfate come from? This is the brown ring. But then, where did the sulfate come all of a sudden? H2SO4 is poured down the sides of the test tube, and then it's an exothermic reaction. The test tube becomes hot. It is supposed to be kept aside for some time, and then the brown ring forms. Okay, if this is formed, okay, here you have to write H2SO4. If this is formed, we know that there is a nitrate radical. This is a test for a nitrate radical. Okay, so this is the brown ring test. Now there's just one more equation which is important, that is KNO3 plus H2SO4. Now this actually you can connect it to KHSO4 plus HNO3. Similar equation we had in preparation of HCl. Okay, now this has to be always less than 200 degrees centigrade. Why? Again, that sticky substance, if we are raising the temperature above 200, then we get K2SO4 which sticks in the test tube, sticks in the apparatus. We don't want all that mess. So here we keep it below 200 and then it can produce HNO3. This is one of the methods to produce HNO3. Okay, and then you have to remember it has to be kept below 200 degrees centigrade. Okay, I just missed something. Here, this acid has to be dilute nitric acid. So that is it from HNO3. Next I'll be uploading is ammonia. So keep watching the playlist, keep checking the channel every day, and do not forget to like and comment as I said. Thanks all of you. Bye then.